All right, one of the last things we're going to cover in our Pythagorean theorem and volume unit is, of course, volume. Now, last year, you should have dealt with the volume of things like prisms. So, for example, boxes. And if you haven't, we'll cover those a little later on in this year as well. Another item you should have covered is the pyramid. All right, and again, if you haven't covered those items, we'll do them later. But right now, our focus in 8th grade is on figures that are rounded in some way, shape, or form. So obviously cylinders, if you've ever had, say, a can of Coke or ever worked with a can of paint, cylinders have 2 circular bases. All right, looks something like that. Cones, obviously, if you've ever eaten an ice cream cone, like a waffle cone, you know its shape. Again, there's that curved bit. And then, of course, spheres. So for those of you that play volleyball, basketball, baseball, a sphere is just a fancy way of talking about a ball. So what we're going to do is we're going to talk about volume. So let's real quick talk about this idea of volume. Volume is the idea of how much 3D space an object takes up. And because of that, we measure volume in what we call cubic units. In other words, we're going to see how many cubes of a particular size will fit into our 3-dimensional object. So how many cubes could I fit inside that cone? And obviously we'd have to take some of those cubes and cut them up to get them all to fit. So because we're talking about cubic units, for example, we could be talking about feet cubed. So maybe each one of these sides of our cube is a foot. We could be talking about inches cubed. So again, every one of those sides would be 1 inch. And see how many of those teeny tiny little cubes could we fit inside of our cone there. So make sure all of your units of measure end with a 3. So for example, if we were talking about, say, 4 centimeters cubed, this cube only applies to the centimeter, not to the 4. All right, so that's just telling us that we're dealing in boxes. If we were talking about, say, area, then that is how much 2D space a figure takes up. And in the case of area, we measure in square units. So, for example, how many squares of a certain size would fit into, say, this hexagon? And again, we would measure those in, say, feet squared or inches squared. So again, how many squares would fit? But our focus today is in volume, how much of this 3-dimensional space we are using. So again, make sure that we're using proper units, proper metrics there. We don't want to be using, say, feet squared or just plain feet. We're not measuring a linear distance or an area measure. We're taking a volume, a 3-dimensional measure. So let's talk about each of our figures. We've got cylinders, cones, and spheres. We'll work through just a real brief example. We'll talk about how to calculate them, talk about your formulas, and that's pretty much it. So let's start with spheres, not spheres. We'll start with cylinders first because they're the easiest. So let's talk about a cylinder. All right. So cylinders, let's draw one, have 2, if I can get my pen to right, there we go, have 2 circular bases. So let's label that real quick. So this is a base, and this is a base. All right, so 2 circles for the bases. So something that you might be familiar with is, say, the prism. The prism has 2 bases, but again, they tend to be squares, rectangles, triangles, whatever. For us, they're circles. There's some information we'll need off of the cylinder in order to find its volume. One key piece of information is measured from the center of base to the edge, and we call that the radius. All right, so we'll need that. It's typically abbreviated with an R. We also need the height, and that's typically measured from base to base, right, and that shortest distance possible. And we typically abbreviate it with an H. All right, the last item that we'll need is pi. Now, some calculators will have a pi button. If not, if you're using, say, a calculator that doesn't have a pi button. So for example, here I don't have, I have a pi button here. Notice it doesn't give me just 3.14, it gives me 3.14, blah, blah, blah. If your calculator doesn't have that button, then just use 3.14 for your calculations. Some tests will tell you not to use that button. They'll say, no, 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 don't do that. Instead, use 3.14. So make sure you pay attention. If it says the use pi button, have at it. If it says use 3.14, then do that. So here's the formula to find out how much space is inside this cylinder. The volume formula is pi times the radius squared times the height. And that's it. It's just that simple. Everything's getting multiplied together. Notice we've got things side by side. That means multiply. So let's look at a real quick example now that we've got all the pieces labeled. I'm going to kind of rough sketch this here. So here's our cylinder that we're working with. And let's say, I don't know, let's draw in this radius. Maybe our radius is equal to something like 1.5. Maybe it's kind of like a pop can. So roughly 1.5 inch radius. And let's say its height is, I don't know, we'll go with 6. And we'll measure in inches in both these cases. So something about the size of a pop can, not exact, but close. How could I find the volume of that figure? Well, we're going to use the formula. So my volume in this case is equal to pi. And in this case, we'll go ahead and use the pi button just because it's handy. But remember, 3.14 is the approximation that we'll use if we don't have a pi button or if we're asked to approximate. That's what we'll use. So we'll just keep pi for now. Times our radius. Well, in this case, we said 1.5 or 1.5. So I'm going to put this in parentheses, 1.5 squared. All right, multiplied by the height, and our height in this case is 6 inches. So all we got to do is type that into our calculator. And remember, that is 1.5, not 15. So here we go. So we'll do pi times 1.5. And in my case, my calculator, where you see that a squared, that's my square button. So 1.5 squared times 6. And then there is our answer. So in this case, the volume, and let's round to the hundredths position. So we've got 4, 1. So the 1's the hundredths position. We look 1 back, it's 1. All right, we drop everything. So our volume is 42 and 41 hundredths inches cubed. So again, make sure you put those cubic units on there. So if I were to take 41 little boxes with each side there measuring 1 inch, I could fit 41 of them into that figure. And obviously we'd have to cut some of them up to make them fit, but we could fit roughly 42 and almost a half of another into something that size. So again, that's all there is to finding the volume of a cylinder. Just take what you know, plug it in, and you are golden. Let's try a new figure. Let's try the cone. All right. Cones are interesting in that they're very, very closely related to the pyramid. So if our ancient Egyptian forebears there had decided to do cones, their math wouldn't have been all that different. Cones and pyramids are almost identical in the math, the way we do them. A few things we need to know. First off, a cone only has one base. All right, whereas our cylinder, we said, had 2. Instead, our cone at one end has a base, and at the other end, it has something called an apex. Sometimes, depending on the book you're reading, they might call it a vertex, typically called the apex, and that's just that point at the top. Some information that we need from our cone in order to find the correct volume. One object that we'll need is from the center of our base to the edge, and we've already talked about what that's called, but we'll write it again. That is our radius, again, abbreviated with R. We need the height. Now, height is, be careful, height is measured from apex straight down to the radius, and it forms a right angle. So you kind of get a right triangle going. So that is our height, abbreviated with H. Here's what you don't want. Okay, we don't want this. We don't want from here at the edge of a base to the apex along this. All right, let me write this in for you. This is called the slant height. All right, and when it comes to volume, we do not want that distance. Okay, no, 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 no. If we're finding surface area, which we'll deal with a little bit later on in the year, then yes, we would want our slant height. But for now, no, 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 we don't want that. But just be aware that it is there. So we desperately need height and we desperately need radius in order to find the volume of the cone. Right? So let's look at its volume formula. It's pretty straightforward. And I'm going to give you the calculator-friendly version. All right, there's lots of different ways to write this formula. I'm going to give you the calculator-friendly version. So in this case, volume of our cone is pi. Again, we're dealing with a circle, so pi is going to be involved. Pi times the radius squared times the height. And if you're paying attention, you realize that our two formulas are identical at this point. So cones and cylinders are very much related to each other. There's just one change. When we get done, so pi times radius squared times height, the last thing that we're going to do, and I know we said we were going to try and get away from that symbol, but I'm going to use it today just to kind of point it out. So pi times radius squared times height divided by 3. Because here's the deal. If I had a cone and a cylinder with the same height and same size base, then the cone has 1/3 the volume of the same size cylinder, right, of height and base. All right, so that's why we divide by 3. So let's try an example. Let's get a rough sketch going here of our example. I don't know, maybe something like that. And we'll say our height is 10 centimeters and let's do a diameter. All right, diameter goes all the way across the circle, and let's say our diameter is also 10 centimeters. All right, diameter, all right, let's write this over here. Diameter is equal to 2 times a radius. All right, because diameter goes all the way across and radius only goes half that distance. So if I've got 10 for the diameter, then I need half of that to get to my radius. So in this case, my height we said was 10, and my radius in this case is only going to be 5 centimeters. Because again, we want from center to edge, we only need half the distance. So let's plug it in. So our volume for this particular cone is equivalent to, and let's use 3.14 this time, just to show how that will work as well. So 3.14 for pi multiplied by our radius, in this case 5 squared, multiplied by 10, that's our height. And then when we're done with all of that, we're going to divide by 3. Again, because cones of the same base and height are only 1/3 of the size of that same cylinder. All right, so let's plug it in. So we'll grab a calculator. So this time I am not going to use my pi button. I'm going to use if it'll type 3.14 multiplied by 5 squared multiplied by 10. And then last but not least, divided by 3. And there we are. And again, we'll round to the hundredths position again. So notice hundredths is a 6. Go over, it's also 6. So roughly 261.67 cubic centimeters. Remember, we're measuring in centimeters, so we're going to do centimeters cubed. So that would be the volume of that particular cone. And again, there's the formula. Notice cylinders and cones, it's almost identical. The only difference is divide by 3. And please make certain that you remember to do this. If you don't, you'll get a number that's too big. All right, well, last but not least, let's look at spheres. All right, spheres are sort of the oddball. No pun intended. All right, let's draw a sphere. Wow, that was a pretty good circle. And then let's draw kind of an equator around it like that. So there's a circle, all right? And spheres don't have bases, all right? No bases. Instead, what we call this circle that goes through the dead center of a sphere, we call it a great circle. And that's the information that we need is from that great circle. And really the only thing we need for a sphere is the radius. Because notice, no matter how I turn the sphere, the radius is the same. Center of the sphere to the edge. There is no real height of a sphere. All right, notice with our cylinder and our cone, we could find a height very easy. Here it is. Here's a height. There it is. With spheres, however, we don't really have that height component. So that's the only information that we're going to need off the item or off our object is just that radius, the measure from the center to the edge. So let's talk about the volume formula because it's a little different than the others. All right, our volume formula, and again, I'm going to show you the calculator-friendly version. All right, there are multiple versions of the formula. I'm going to show you the calculator-friendly version. All right, so here you go. It is 4 times pi times our radius, and this time the radius is cubed, not squared. So that's a point of contention. Be careful. So 4 times pi times the radius cubed divided by 3. All right, so that's the formula. And let's talk about how we'll use it. So we'll get us a quick example here. I don't know, let's do the volume of something like a tennis ball. All right, or something close to that size. So a tennis ball's radius here, let's say it's roughly, I don't know, this might be a little, maybe a softball. We'll say our radius here is 2 inches. All right, because that's about the size of a softball or a grapefruit, something like that. So let's find it, and that's all we need. We just need that radius measurement, and we're off. So our volume is equal, we keep 4. 4 is just a part of the formula. Times pi, and we'll use the pi button this time just to make it type a little faster, times our radius, in this case 2 inches, so 2 to the 3rd power, and we'll talk about how to type that in, and then divide by 3. And again, this is the calculator-friendly version since most of the time we're going to do this work with the calculator in tow. So here we go. So 4 times pi, so I'm going to use my pi button, times 2. Now, some calculators will have a cube button, like we have a square button. All right, in this case, my calculator does not. What it has is this AB button. So I'm going to press it, and notice it goes up and allows me to write that superscript 3. For our calculators in the classroom, the button that you'll want to use looks like this. It's called a caret key. So you'll push that, and it'll let you type in that exponent of 3. So I'm going to arrow over to get out of that exponent, and then we're going to hit divide. Oop, excuse me. Back that up. Well, here's what we'll do. We're going to go ahead and hit enter, and then we'll do divide. Well, it's just not playing ball. Divide. Oh, it's not going to play ball. That's fine, by 3. I really wish it would push it off to the side there. I wonder if I can make it do it. No, not with that button, I won't. Let's see, clear all. 4 divided by 3. Well, it's just going to do it. It'll be fine. 4 times, what do we say, pi times 3, or excuse me, 2 to the 3rd power. And then we'll take that and divide it by 3. Divided by 3. Yep, that'll work. Or excuse me, yeah, 40. Yep, we typed it all right. That'll be fine. I don't like the way it's done. Again, I'd rather it look like that. And in your TI calculator, it would look the way I would prefer it. It would be 4 times pi times your 2 caret key 3, and then it would have that division slant 4, which I think is a cleaner way of writing it. Both of them will get you the same answer though. So volume is equivalent to, and we'll round to the hundredths place again, so roughly 33.51, and we were measuring in inches, so inches cubed. So if we had roughly 33.5 of these cubes that all measured 1 inch by 1 inch by 1 inch, we could fit 33 of them into that softball, tennis ball, something along those sizes. Size ball, and they would all fit in there. Obviously, we'd have to squish some of them in there, cut a few of them up, but they would all fit, roughly 33.5 of them. So that's what we're going to be dealing with today is volume issues. So again, the sphere, there's your formula. Make sure you write that down. The cone, again, volume formula. Make sure you've written that down. And then the cylinder, again, formulas here. We'll be working with these today, and then later in the year, we'll go back and touch on prisms and pyramids if you don't remember how to do those. All right, we'll see you in class. Make sure you bring any questions that you have. Have a good day, folks.